Hello friends, welcome to this video on the topic learning from multiple representations. I am Shomir Roy, Professor of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, Kolkata. You have already gone through the first part of this topic, learning from multiple representations. This is the second and concluding part. In this part, we will discuss the subtopics personalized recommendation containing topic-based content recommendation and course recommendation, as well as some case studies. After successful completion of the entire unit, you will be able to describe the principles and techniques of learning from multiple representations and initiate process for applying the principles and techniques of learning from multiple representations in teaching learning. Personalized recommendation. A state-of-art e-learning platform should be able to provide learning contents in a personalized manner, taking into consideration the students' preferences, interests, background knowledge and capacity to memorize information. This is what is known as personalized recommendation. Basic idea of personalized recommendation is expressed in this figure. A user profile is created by extracting the features of the contents used in past by a user. This user profile is matched with the profile of the contents created and on the basis of their feature values. Then the contents with similar features values is recommended to the user. Two important categories of personalized recommendation are topic-based content recommendation and course recommendation. Let us see what is topic-based content recommendation. In contemporary e-learning domain, topic-based content recommendation is gaining importance. Knowledge discovery from large data pool is a non-trivial task. Two popular techniques, namely content-based filtering and collaborative filtering, are usually employed in recommendation systems. Content-based filtering strategy can be described as follows. If user X reads 2 articles on the topic of machine learning, then the system can recommend a paper on deep learning to him. On the other hand, collaborative filtering strategy may be described as if X and Y are similar users and user Y likes the article A, then the system can recommend article A to user X, even though X has not read any article similar to A. The former technique uses item-to-item relation and makes recommendations on the basis of the contents. In contrast, the latter technique is based on user-to-user relation and provides recommendation on the basis of user behavior. Content-based filtering has the following steps. 1. Data pre-processing. 2. Vectorization. 3. Latent vector analysis. 4. Similarity measurement. The goal of vectorization is to obtain numerical features vectors from the documents. It produces a document term matrix containing scores of terms for each document. There are different methods to calculate the scores. The simplest way is to calculate the number of times an item is used in a document. Another way is to calculate the TF-IDF, namely term frequency inverse document frequency. While TF of a term is simply its frequency in a document. IDF is defined to be the inverse of the frequency of document among the entire corpus of documents. TF, IDF are defined in the following way. TF-T is equal to frequency of occurrence of term T in document divided by total number of terms in the document, and IDF-T is equal to log to the base 10 total number of documents divided by number of documents containing the term. The TF-IDF pair indicates the importance of a term in a document with respect to a document corpus. The importance of the term increases proportionately to its frequency in the document, but is offset by its frequency in the whole corpus. Certain words such as the, a, for, in, etc. usually have high scores even though these are not semantically important. TF-IDF is used to determine the relative importance of the terms to overcome this problem. Here are the steps of the content-based recommender. Step 1. Prepare the document term matrix through preprocessing and vectorization. Step 2. Extract latent topics using topic modeling technique on document term matrix to prepare the topic word matrix. Step 3. Based on the topic word matrix, compute the topic probability for each document. Step 4. Prepare a document term matrix from the user input document. Step 5. Compute topic probabilities of the user input with the help of the topic model. And step 6. Find similar documents using a similarity metric from the outputs of step 3 and topic probabilities of the user input. The high-level architecture of the content-based recommendation system is shown in the adjacent figure. The source of this figure is mentioned in the e-content. The process starts with content analyzer, which employs information retrieval techniques to obtain the item descriptions coming from the information sources. The content analyzer extracts features such as keywords, n-grams, concepts, etc. from the text to create a structured item representation. This is kept in the repository of represented items. The filtering component is used to rank items of interest according to their relevances. The list of recommendations which is presented to the user are formed with high-ranking items. Up-to-date information is stored in the profile learner. Since the taste of the user changes with time, there is a necessity to store updated information. Profile learner automatically updates the user profile on the basis of feedback. Course recommendation. Course recommendation can be defined as the activity of suggesting the best combination of courses suitable for a particular student. This figure presents the main architecture of the proposed course recommender. Please see the e-contents for the source of this figure. The goal is to recommend courses to the learners through hybrid filtering combining content-based as well as collaborative filtering with ontology support. There are 4 layers in the system. The first layer, that is the data gathering, consists of all data sources and the data collection model. Its role is to obtain useful data from various resources. All items and user data are stored in a database which comprise the second layer. Next comes core of the system, inclusive of the ontological model and the recommender engine. The fourth and the final layer is the user interface through which the system interacts with the user and provides the recommendation and other feedbacks. The steps of a recommender system are here. Step 1. extract useful data from various resources. Step 2, create the profiles of the courses using the course features, considering ontology hierarchy among the features. Step 3, develop student profile on the basis of student data. Step 4, establish link between the user profile and item profile through dynamic ontology mapping. Step 5, compute similarity between course profile and user profile and analyze the queries of the user. And step 6, obtain the topmost n users who are similar to the present user. The list of courses to be recommended to the student is the outcome of this last step. Let us now consider a few case studies on the topic of learning from multiple representations. S. Krizanik has reported a case study where data on 185 students of an e-course was analyzed through the k-means clustering. The process returned 3 groups with 84, 82 and 19 students. Clusters of students were created on the basis of the frequencies of access to the e-contents. It was found that students who accessed learning materials more frequently achieved higher results in the examinations. E. A. Ibrahim has reported a study to find the factors affecting the learning achievements of grade 10 students of Ethiopia. He surveyed 719 students of grade 10 from 11 secondary schools. Various methods such as descriptive analysis, factor analysis, multivariate multiple linear regression analysis were applied to analyze the data. It was found that factors such as gender, school facility, motivation and interest, family status, etc. have remarkable influence on the learning achievements. Nishino et al. Have reported a course recommendation system for e-learning students. It is an extended learning management system that recommends e-learning course based on students' learning preferences. In order to provide a learning system that matches the students' learning preference, they established that the adaptability to an e-learning course can be estimated a priori on the basis of learners' answers to questionnaires. For further details of these case studies, please see the e-material. With this, we have come to the end of the lesson on the topic learning from multiple representations. Moreover, this is the last unit of the course. Hence, we are now at the end of the entire course on data analytics. Thank you for your kind listening. I hope you have enjoyed the course. Please go through the e-contents for further details. Once again, thank you very much and see you again. Have a good day.